Good morning, good afternoon, and good evening to all of you, and welcome to our Value Chain Innovation Speaker Series. My name is Barchi Gilai, and I'm the Associate Director of the Value Chain Innovation Initiative at Stanford Graduate School of Business. We're excited to host today Michael Marks, a founding manager partner of Celesta Capital, which is a global deep tech venture capital firm based in Silicon Valley. Marks is a seasoned executive with more than 40 years of experience leading and transforming tech companies. Among his many accomplishments, Marks played a pivotal role in turning Flex, a global manufacturing services company, into one of the largest technology companies in the world. Currently, Marks serves as a board director for more than 20 companies. He has also served as an adjunct professor at Stanford Graduate School of Business. In today's event, Marks will offer insights into how artificial intelligence is impacting the business world today and how executives and investors are thinking about the opportunities for AI to drive value creation. Moderating the discussion is Haim Mendelson, who is a professor at the Stanford Graduate School of Business and the faculty director of the Value Chain Innovation Initiative.
Thank you very much, Barchi, and Michael, it's great to have you with us.
Thank you. Great to be back at the business school.
And so I'll start with a bit of a question about your background. So you've played many different roles. You've been the CEO of a large company, you've done private equity, venture capital, you've taught here at Stanford, and more. Which of these roles was the most fun?
Well, they're all fun in different ways. And, as we were discussing, I tend not to stay in jobs that aren't fun. So I stayed in the private equity world only 1 year at the high end. And but all the rest of them have been very interesting. I mean, venture capital, which I'm doing now, is incredibly intellectually stimulating because there's just so much happening in the world. I'm sure we're going to talk about it, but it's fascinating.
Can you tell us a little bit about Celesta Capital? What do you do? What do you specialize in? How do you do it?
Yeah, sure. Well, technology is such a broad conversation these days. We tend to focus in 3 areas, and we tend not to have rules. In other words, we'll go outside of these areas. But in general, about half of our business is hardware related. Both of my other general partners were also operating executives in the hardware world. One at Flextronics with me, Nick Brathwaite, and one at Intel. And so we're very connected in the hardware world. And so about half of our business is somehow connected to hardware. We can talk about what's driving all of that. It is where venture capital started in Silicon Valley 40 years ago. And it's kind of come around now to us being the cool kids on the block again because of Jensen and what's going on with NVIDIA and Broadcom and these others. About 25% is artificial intelligence, but at the domain expertise level. So, and I qualify these as like OpenAI and all the stuff people talk about, the large language models. Those are tools, and we don't participate in the tool side. So we participate in companies that are using artificial intelligence to change the way a certain segment of the business works, whether it's in radiology or it's in how lawyers work or those kinds of things. So that's about a quarter of it, and a quarter of it is in what we call bioconvergence, which is kind of a weird word, but we call it that because it's where biology meets hardware, and that this is an exploding area. We do about a quarter of that. A lot of it's medical diagnostics, and we have one company that's doing incredibly innovative stuff in drug development and so on. So those are the 3 basic areas.
So these are very broad areas of technology. So how do you stay on top of all of this?
Well, we don't really. How do we stay on top of it? Well, of course, we have experts in the group, but more to the question, it's what's great about Silicon Valley to be in the venture world, and I'm sure and all the listeners know, every major city in the world has wanted to be the new Silicon Valley, and none of them are. And it's because there's so much depth of technology here, and there's so much interaction. It's just like what we're doing today. There's so much discussion, and there's a big NVIDIA conference going on right now, and everybody's over there listening to Jensen doing his thing. But that's what makes this area so great, because technology and technology trends people who are doing things are very accessible in this very small area in which we live. Whereas, if you're living in London and you want to do technology, it's going to be a lot harder. So it just happens all around us. It's really fun.
So when an entrepreneur comes to you and they have a new technology, it's very deep into a specific area. What do you do to evaluate it?
Well, it depends. That's a great question. We have advisors to our firm, and what most people do in the private equity world is all this list of advisors, and it's sort of window dressing. That's not the case with us. We have, 3 or 4, advisors who are helping us to evaluate. The classic example is in the biology arena. One of our advisors is Jim Rothman, who won the Nobel Prize in biology. And so we're calling him up all the time going, Jim, does this make any sense or not? We have these advisors who have very specific expertise. We also use the CEOs of our companies, and we have 70 portfolio companies. There's almost no new technology that doesn't touch other examples. So we'll go to those CEOs and say, what do you think about this? And so that's pretty much how we check them out. The other thing I would say, and it's one of the things that I say a lot, is that our companies rarely fail because the technology doesn't work. They mostly fail because they can't run the business. So we're not just evaluating the technology, we're also evaluating the entrepreneur, the team themselves. We'll do due diligence about that. We'll see where else they worked. We'll see what kind of reputation they have, because that tends to be the bigger problem in terms of developing real companies.
So would it ever happen that an entrepreneur comes to you with great technology and you're saying, yeah, this is good technology, but we're going to think about replacing that entrepreneur in 2 years?
That's a really good question. Thank you for that. Yeah, I haven't really been asked quite that way, so thank you for that. Yes, in fact, I can tell you that there are 3 specific instances just in the last couple of years where we said that we would invest in the company, but only if the entrepreneur would allow us to hire a CEO there. And typically you have them go to chief technology officer or chief science officer. And in all the cases, they agreed. And in all the cases, we did make the change. And in all the cases, the companies have done really well.
That's great. So they want to make money.
But that's tricky, if you're asking, it's tricky. Well, there's a lot of people who wouldn't agree to it, right? I mean, there's this whole concept in Silicon Valley being founder friendly and, all that stuff. And some people won't because they really want to run it.
Yeah.
But if they do, then we just don't invest.
So one of your partners has become the CEO of Intel.
Yes.
Can you tell us about that?
I can. Yeah, and now that it's very public information, we can talk about it more directly. He's a longtime friend of mine and a partner. He was on the board of Electronics. He and I started this firm together. Had a different name when we started, but so I've known him for a long time. And I've also known Intel for a long time, and I think everybody knows it's really been a struggling company, and it's a sad thing that it's a struggling company because it's been so important to that ecosystem I was talking about earlier. Intel has gotten a bit behind. It's all very public. I mean, behind on the processor technology and behind on the foundry side. And they've gone through multiple CEOs. It's a place where good reputations can go to die. So this is something that Lip-Bu had to think very seriously about. He is absolutely the right person to do this, and he's the right person. Not only because he's a good executive, he ran Cadence, he did an unbelievable job. I think the stock went up from 3 to 103 or something while he was there. But he has experience running businesses. But even more important, Intel to survive is going to have partnerships now. I mean, it's not going to be able to innovate its way out of this. And there's all this discussion about, other, Broadcom and Qualcomm and these kinds of companies, and also TSMC on the foundry side. And all these people, Lip-Bu knows well, they respect him, they trust him, they know that they're going to be able to, to work with him and Intel to help them make changes. So I think he's absolutely the right person for the job. I'm obviously optimistic because I'm a friend of his and believe in him, and I think it'll work out. But this is a road. They got some work to do.
Do you think they should continue with the integration of process and design?
That question is really above my pay grade. That's another good question, though, and it's one that people are talking about because I don't really know the intricacies of where they are. They are very different businesses to be in the foundry business versus being in the technology development, hardware business. They could be synergistic, but nobody else does it. So you can say if nobody else does it, then is it really a good idea? That's obviously one of the big important things that Lip-Bu's going to have to sort out early.
Yeah.
Yeah.
So let's turn to AI.
Okay.
Do you think that AI is overhyped, underhyped, both?
Oh, it's definitely overhyped. It was so funny. I was at Davos this year. I hadn't been in a bunch of years, and I went to this McKinsey hosted a meeting with all these fancy dancy CEOs all around, and we were talking about leadership and stuff like that. And then I opened it up for questions. And one guy got up and said, "Before I ask my question, I want to say it's such a relief that we've spent an hour and nobody said anything about AI yet," and answer the question about being overhyped. It is not overhyped in the sense of, I mean, this is obviously stating the blindingly obvious. This is a new transformation, in technology. We've seen them before. I mean, we're all, you look around and say everybody has a cell phone. 15 years ago, cell phones didn't exist. They've changed everything. AI is going to change everything. And so if you were to say, is the cell phone overhyped? No, not, and AI is not overhyped in the sense that this is a really important, it's a new technology, and the ramifications are endless, and it's difficult to see the future. On the question of whether it's overhyped, it definitely is. And what I mean by that is people are making these projections. I'm going to give you an example, but people make projections about AI is going to do everything for us. Sometimes some of the stuff is so ridiculous. I'll give you two examples about this. I think they're kind of amusing. One is you'll read this stuff that AI is going to take on a life of its own, and robots are going to make other robots, and and the human race is going to be extinct. And I keep asking myself, let me see how this works. So in order for robots to build robots, they have to have factories. So they're going to be building this factory down the street. We're all going to be sitting around going, I wonder what's going on over there. I mean, it's like the concepts are ridiculous. Let me give you another example, and this is a good one. We at our firm, we have a podcast called Tech Surge, and we just did one with the CEO of a drug development company. It was on the question of, is AI able to develop drugs? And there's all these people out there saying, AI can develop drugs. We're going to have individualized drugs for everybody. And our guy, the CEO of our company, Mike Nohaley, said, I think that might happen, but that's at least 3 decades away. And he starts by saying, if AI can develop drugs, where are they? There's not a single drug out there that has been developed by AI. So, and we could go deeply into that, but the point being, it is so easy to make these forward-looking projections without a founding in technology. Like you can't develop drugs without a start in biology, and AI can't start biology. So it's that kind of stuff. Nonetheless, let me not mislead our listeners. We all know that this is a big deal and an important deal, and it's fun and interesting.
So since we're talking about biology, can you tell us about some of the companies that you invest in this area?
I can. But, kind of a classic, a lot of it's medical diagnostics. So I can give you just a couple of examples. One of the ones that we've been in for a long time, and it takes a long time on the artificial intelligence side, it takes a long time to develop the data and do the testing and make sure that's right. And when you're talking about treating humans, you can't have hallucinations. That's not going to work. And so this is a company called White Rabbit. We've been for a long time, and we're using artificial intelligence to read mammograms. And mammograms, for the audience, if you don't know, are notoriously terrible in results. And I can quantify that. It's between 15 and 20% false negatives and false positives. A false positive, we say you have cancer and you don't. You get a biopsy and go through all this stuff. It's painful, it's expensive, it's traumatizing, but it's not life-threatening. But a false negative, we say you don't have it and you do. That is a serious problem. And so when you think about 15% of mammograms, of women get false negatives, that's horrific. So right.
Couldn't the people who interpret it be more conservative on one side and change the
I think it's
percentages?
no, again, thanks for that question. No, I don't think it's a lack of capability. It's that the information is so dense. This is what artificial intelligence computers do the best at. They can process more information quicker than the brain can. There is an interesting statistic, which is also shocking, which is there is a high correlation between the accuracy of mammograms and whether or not they're read before 11 o'clock in the morning. And that goes to the issue that you're asking. I mean, this is very dense, complex information, and people get tired. And so as the day goes on, it's more difficult. So this is a perfect. Now let's go to the artificial intelligence side of that. So in our artificial intelligence at White Rabbit, if we say you don't have it, we're right 100% of the time. If we say you have it, we're right 96% of the time, which is still way better than radiologists. But now we're in front of the FDA, and I'm not negative about the time it takes. We all wish that the FDA and all it would work faster, but it's not the FDA being inefficient. It takes a lot of data and a lot of corroboration to make sure that we're not harming human beings, which is what the FDA's job is. But we've now been doing this for 8 years, and our data proves that we can do a better job than radiologists. But in answer to your question, kind of coming around a long loop, the best thing is have artificial intelligence and the radiologists working together. That's the best answer. And when people always talk about AI is going to just replace everybody, no, it isn't, because people actually are pretty good. So that's a cool one.
So you've already answered my next question,
which
was, will AI replace people?
Yeah, no.
Let's drill down on that. So let's say we always need to have a person in the loop.
Yes.
But isn't it true that, we're going to have an improvement of 30% and then 40%?
Yes.
So the role of the person is going to shrink over time.
Correct. And it will take some jobs out. I mean, I don't want to be just, overly trite about these things. But in radiology, which I happen to know about because it's one of our companies, there's a shortage of 500,000 radiologists in the United States. So the fact that AI is going to alleviate the need for that is a really good thing. That's one thing. Second thing is, there is no question, I don't want to say this in the wrong way, we can use AI in our company and replace all the radiologists and do a better job than they're doing. But that's not the optimal outcome. The optimal outcome, think about this. If we say you don't have cancer, we're right 100% of the time. Think what that does to the radiologists. It's like immediately they don't spend any of their day doing that. Obviously, that's a reduction of labor, which if you want to look at it that way, is a reduction of people and jobs. But now that doctor is can concentrate their effort in getting to the right answer. But of course, this means there are going to be less radiologists required. That's a fact.
And would that also change the role of the radiologist to improving the AI system to some extent, or?
Well, no, yes and no. The AI requires data, so they have to provide us the data. So what happens is the hospitals, the radiology practices, they have to provide us with the data. And diseases evolve, which is the body evolves and systems evolve, and so you're always going to be constantly upgrading with new information. That does require interaction with the people who are providing the service.
And how did White Rabbit get the data to train their system?
Well, so we bought it basically. Well, we actually started, to be factually correct, we started in a partnership with Washington University in St. Louis in their medical department, and they not only gave us a huge number of mammograms, but they annotated them. And this is the trick in AI. You can't just take the data. You have to have somebody go, this is cancer, this isn't. And that took a few years, actually. Beyond that, we went and acquired data sets. And the data sets are just, medical records that hospitals have and healthcare systems have.
And over time, it's going to be just experience running the system.
Yeah, we'll get better and better and refine it. But as I said, diseases evolve, so we have to continue to, this isn't a static system.
And can the same technology be used in adjacent areas?
Yes and no. We have another company called 5C. It's actually an Indian company which does which uses artificial intelligence to do other kinds of see if you have a broken bone or if you have liver, inflamed liver. So and the process is similar, but the data is very different. And so yeah, I mean, I think this all could be one massive company in a sense because it's the same activity, but it's very different data sets and how those things are employed and what the regulatory bodies require is different. So, but they're similar.
That's great. So let's turn to another area. Let's look at semiconductors. So deep technology, crucial technology.
Yeah.
Can you give us an example of the use of AI there?
Well,
or the use or a company that improves. Yeah.
It's really a different a different point of view. I mean, we aren't in the AI processor business, but I know a lot about that. Obviously, what NVIDIA is doing. We have a couple of companies in the space, Recognize and Auradine. There's others, Grok and Cerebrus, and people know about them. Those are not improving AI per se. They're improving compute, and AI requires a lot of compute. But AI is changing the hardware. You want to go into that part of this?
If you want.
Well, sure. So this is one of the most interesting things, and I'll go back to some of the opening remarks. AI is a technology. Everybody's talking about these tools and large language models, and people are pretty in tune with what's happening in the data center because everybody's talking about spending, Microsoft and Google and these guys are spending $100 billion a year to build data centers. And all that is because AI queries, inference, takes a huge amount of compute power, and the compute power is in data centers. Well, the impact of that, which is what's made NVIDIA now worth $3 trillion and Broadcom's worth $1 trillion and Qualcomm, all these things, is how much demand there is for their product. But that's the very top of the stack. That's what everybody reads about and sees about, and these people have become rock stars, and Jensen Huang and Hock Tan at Broadcom and so on. What's under the hood is that in order to be able to do this, the entire hardware system in the world has to be completely redesigned. And that's just to be able to handle AI queries, right? So everybody talks about the AI queries. Down here, it takes so much energy. You read these articles, there's not going to be enough electricity in the world to power all the data centers. So what that's doing is it's causing an enormous amount of innovation in everything having to do with hardware. So not just the processors. And in fact, Jensen, I think, just announced yesterday at his conference that their new technology is going to use 1/10 of the power and be faster and all that kind of stuff. The normal evolution. But you've got this in memory, you've got it in I/O, you've got it in how circuit boards are able to work. You've got all these little things, timing chips. I mean, things that nobody thinks about, nobody talks about, but are absolutely critical to the future of our world because of the AI revolution. So now you've got this scrambling, and it's so fantastic to see all these entrepreneurs. I have this little chip that uses 1/100th of the power of the last one. And, these companies are exploding like this. And it's so cool. I just call it the remaking of the stack. At the very top of the stack is you have data centers, there's giant, and energy, and you see people using nuclear power to do all that kind of stuff. But down here in these circuit boards and the things that are in our cell phones, they all take too much energy. They're expensive, they take too much energy, and they're not fast enough. And so now, and this is going on for the next 20 years, totally redo of all that stuff. And that's right where we live. So it's really cool.
And what will happen to traditional data processing? It's also important. Your bank account has to work and stuff like that.
You keep asking me questions that are above my pay grade. I don't know. Change is so fantastic. If you're here, teaching at the business school, or you're, investing in technologies, because the future is unknowable. But being a part of of creating the future is really cool. So there's a lot of questions like the one you answered. I can't answer, but they're great questions, and we spend a lot of time thinking about what are the implications of these things. It's cool.
So back to the company what does the company that's funded by Celesta Capital do?
You about on the hardware side?
On the hardware side, yeah.
Well, we've got a bunch of them.
So let's talk about one of them.
Yeah, let me just pick one because I can actually pick two that I think you'll find interesting. Because when we talk, well, it'll be pretty obvious when I talk about what this company does. It's called Eliyan, and it's so far down in the weeds that nobody would pay attention. Yet it's such a cool company. So I think everybody knows that these chips, the NVIDIA type chips, are giant. They take really big wafers. They're really, really expensive. TSMC charges between $30 and $50 million now just to make a mask set for a chip. They're so big and so complicated. And the reason they're so big is because they have to put all this stuff. And by the way, and for those who don't know in the audience, the bigger and more complex a chip it is, the more difficult is the technology, in order to create it. And then, of course, the more expensive it is. So everybody would like it if they could have smaller chips that are less complicated. But today they can't. They have to have these big chips. And on these big chips, there's memory, there's processing. And the reason they're all in a single big chip is because they can't get the information back and forth. So, if you had memory outside of the processor, at these really high speeds, you wouldn't be able to get the electric signals back and forth. So you have to put it all in the same giant, expensive chip. So we have this company, Eliyan, that has come up with a solution for this problem. And what they've done is created a silicon-based fabric. I mean, just think about it, like a ribbon that has incredibly high speed ability to run enormous amounts of information on a little strip of silicon, so that now you can take this big chip and break it up into smaller chips, which in the industry are called chiplets. Now you can take this big chip, make it into smaller chips, because you can attach it to this fabric and accomplish the same thing you were doing on this giant chip. Now you have, let's say, 4 smaller chips. And now the cost of those 4 is way lower than the cost of having them all be in a giant chip. So here's this little company. Nobody would have to pay any attention to this stuff. And it's going to be worth $1 billion in no time because it solves such a significant problem. And they're developing the technology, but it's starting to work and everybody's getting interested. And, one of the big guys will buy them at some point. There's an example. I have another one that's equally sort of silly when you think about it. If people know about crystals and timing, all computers have a timing, chip. They're usually crystals, that keep everything running on time. So this little company called Stathera came up with a MEMS-based, it's a silicon-based timing chip, if you will, that's like uses 1/100th of the energy of a crystal. And now all the big players are going, you have to use that. This company is less than a year old, already has 3 offers to acquire it in the $300 to $700 million range. That's big money in the world of early stage venture. And, they haven't even got the chip out yet. So these things are fascinating. We love this little stuff. And there aren't many people who do what we do in this area. And it's fantastic stuff.
That's great. Let's turn to the third area, applications. What's your favorite applications company, or what's one of them?
Well, we have a bunch, but my favorite one, it's also difficult, is a company called Percipient. And if the listeners know about Palantir, which does a lot of work for government and uses artificial intelligence and stuff and uses predictive analytics to do a lot of government-like work. This is a company that does what Palantir does, but with visual images, which are very difficult and complicated, really interesting stuff. I'll tell you just a new application that came up this week. But before I talk just about the company, this is a company that also is 8 years old. This is where people are confused sometimes when they think about artificial intelligence. We talk about it. This isn't brand new. I mean, White Rabbit using artificial intelligence to read mammograms, that company started 10 years ago. This one, Percipient, which I'm about to talk about, started 10 years ago. because that's how long it takes to use these data sets and create things. And the fact that these large language models, are sort of sucking up all the oxygen in the room, everybody should remember that AI has been going on for a long time. It's getting better, the tools are helping, and so on. But this is a company that takes images from satellites and drones and cameras and basically merges them all and can find the bad guys. So what does that mean? So actually started by a general in the Air Force, and the old systems that we're replacing, this is military systems, defense. You have satellites looking at a camp in Afghanistan. He actually served in Afghanistan. So you have a satellite looking at this, and there's a suspicious looking truck that maybe has bombs in it that's maybe it's going to blow up the camp. By the time the software would sort out that this is a risky, problematic thing, that camp's gone. It was gone a week ago. So because this is technology was developed, 25 years ago. So what we're developing is new systems for that to make it much more real time. And we're really starting to win lots of business in the military for this reason. This is brand new. It's way better. And this software, it's breathtaking to watch. But like in an airport, you could say, you tell the system, I'm looking for somebody who's wearing a big gray sweater with black and white on it. It's got a white beard. And it'll find that person and track them, watch where they're going. We'll also go back in time to see what that person, like if they've been casing a place. And this is a sad part about this story, but, because of the murder of the executive in the New York City streets, I mean, all these companies are, wanting to protect their executives. And this is a way of having, because you can take all this camera data, wherever it's from, and merge it and follow and see if people are stalking. And we just started working with one of the biggest, retail store chains. I won't mention their name, but people case these places, and there's gangs that go into to shoplift. They usually shoplift pharmaceuticals. And these companies know who they are. They know what kind of cars they drive. They know what kind of tattoos they've got. And what we're starting to do is do a test so that we can detect when they're coming into the parking lot, and then we can let the security know so they can meet them at the door and not let them in, right? Apprehend them. So that's always a cat and mouse game, but that's what this technology does, and we're really proud of the company. They've done a lot of hard work for a lot of years getting to revenue, and it's important for our country, so I feel really good about that one.
And it essentially creates an alert and an interpretation
Correct.
goes with that alert.
That's exactly right.
And is there a person in that loop?
There is a person in that loop because somebody, you could probably take them out. But yeah, and answer your question, the data, you said it exactly right, Haim. It's, you get an alert, then you can tell the system, follow this person. Show me every place.
And that's
this
a person
person's,
tells.
that's a person telling the system what information they now want to see.
Wow,
Yeah.
that's interesting.
Yeah. And again, there's not enough of those people around either, right? I mean, the people who do this work. So, back to a question you asked earlier, this system does things no people can do. But then people can use the system to do the things that the people need to get done, which is protect the airports, protect the executives, protect the country.
That's great. The question is really, which sectors do you see the fastest adoption of AI? So the emphasis of the question is in terms of adoption, we have great technology, but it's going to take time to get it adopted. In which sectors do you expect the adoption to kind of be faster, as has already happened with LLMs?
Yeah, that's a good question. It's a difficult question. It's a nuanced question. Where you will get the fastest adoption is where you have the biggest need. Now, if you can take regulation out of the system, I'll just talk, regulate it. So look at medical. I mean, medical, we're really bad at medicine. I mean, the world's bad at medicine. Drugs don't really work very well. Diagnostics, we talk about diagnostics, aren't really particularly good. There's a really big need, but you can't go that fast for the reasons we've talked about. But there's a huge amount of demand there, and as the regulatory approvals come into place, there will be massive adoption. So in that one, for example, the healthcare systems who are paying for insurance. I mean, they're desperate to have what White Rabbit does because all these false negatives and false positives just add cost into the system. So there's huge demand. As soon as it's approved and works, it will be adopted massively quickly.
So are you saying when the benefits are large enough, all the resistance to change is going to melt?
I think that's right. But let's take a more nuanced part of this. Let's just take a business adoption. I mean, managing your bank accounts, these kinds of things. The consumer usage is going to be much slower, and companies that provide services to consumers will try to use it, but people don't adapt to new technologies very easily or very quickly, right? So while there may be tremendous value, the demand side may not be as great. So that's why I appreciate your question, Danny. It's very nuanced, but there is no boardroom in the world today where people aren't going, what are the implications on our business from AI?
So in the business world, value wins.
Yeah. Yes.
Another question, Danny. Do you think there is a lack of data or access to data to train AI models? And how easy is it for AI developers to buy data to train the AI models? And I'll augment the question. So what do you think about the scaling hypothesis? And is data, as the question suggests, kind of a limiting factor there?
Data is definitely a limiting factor. There's no question. It's one of the reasons you have hallucinations, in which are, if you don't know that term, it's where you get a result that isn't accurate. I mean, the reason for that is because you don't have enough training data, and to make, again, each individual application is different, but data. Let me give you an example. So we have a company, Clairvolex, which uses artificial intelligence to do patent work. Is this a good patent? Is this a bad patent? I mean, where's the white space? That where if you want more IP control, you should be doing patents here. To be accurate, and that takes a ton of data, and a lot of it just doesn't exist, right? So you can go into the patent, see who's filed patents, where there have been lawsuits, blah blah. But this is going to take years, if not decades, to actually do. Now, so what happens is you get these groups will take a subset. Let me do telecommunications IP work. But as opposed to I can do this for everything. You just can't do it. There isn't enough data. And on the question of can you buy it, it all depends on the data sets. I mean, people who have data want to sell it generally if they're not using it for their own use. And so there is data available, but there's for sure not enough to train all these systems.
And what do you think about synthetic data?
I probably shouldn't make a very big answer because that's more of a scientific question, and I'm not a scientist. I know that our companies do use synthetic data, but I can't really. Obviously, if you can use synthetic data, you have more data. But I think this whole data question is one that takes many, many years to get sorted out, and different in different categories. But I don't know enough about synthetic data to go deeper.
Right. Let's go to. Vasil has a question. First of all, thanks you for this amazing webinar.
Oh,
so that's great.
Thank you.
And his question is, thinking of one of the common rules of data science, garbage in, garbage out.
Yeah.
How do you ensure that the labeled data that you receive in partnership is not containing some garbage?
Well, it almost always does. Yeah, it is garbage. I mean, that just goes back to how much data you need to resolve those issues. Because if you don't have very much data and some of the data is faulty, you're just not going to get a good answer. And data, going back to what I said about the Washington University scientists who are annotating, doesn't mean they're perfect every time they say this cancer or it isn't. They're not perfect either, which means that some of the data is faulty. And it always will be. This is, it's not malice aforethought. It's just that there's always going to be faulty data. The way you deal with that is having a lot of data and then continuing to train your system. And when you find mistakes, go like, what was that mistake? How do we get more data? It's interesting on the White Rabbit thing. So we're in front of the FDA, and we haven't tested every data set in the world. It's not possible. So, you have different populations. And so they're going like, well, you have data from, New York and San Francisco. You really better get some from Austin and Poughkeepsie, because maybe those are different populations. That's a perfectly legitimate question. But it goes to this question about how much data does it take? It takes a lot of data in order to really refine these systems. That's why these things aren't happening overnight. They'll take a long time to get right.
Couldn't you have an AI system that identifies suspicious data?
Yes.
And then a person says, yeah, this is junk, or or they might say, this is a big signal. This is something I didn't think about.
That is part of the process. And again, thanks for that question, because people don't ask that very often. That is a part of the training of these AI systems, right? So you train them, you check it against the data. You have people who, all these things start with people who are looking at this data, and that's one of the key things I'll do is like, how do we identify, if you have a data plot, there's data out here. How do we find that data? And yeah, that's a part of the process. And frankly, if you go back to the venture business that I'm in, part of our decision making is, are these people going to be good at this or not? Because not everybody is.
Let's go to the next question from Aditya Narayan Nayak. If I would like to build an AI that can project neurological from MRI films, how much actual reports data required to train a model to just work 70 to 78% efficiency? So this is somebody who wants to compete with you.
Yeah, that's really not a question I can answer. If I could, I would. I mean, the reason I can't answer is because every specific use case is specific. How complicated, are the data sets? How big is the problem you're trying to solve? And I'm just not I just couldn't answer that question.
So the answer is it depends.
It depends.
You mentioned being part of developing the future is cool. Given your long and broad experience, what domains or opportunities do you regret having missed or would like to be in now that you're not? So I guess this is a biographical question.
And the question is, what trends in technology that I've missed?
I think what he's asking is two things. One, what have you missed in the past? And two, what are you missing now and would like to be in?
Yeah. Well, I'm going to answer a slightly different question. One is, I don't have any regrets. I'm one of these people, and not everybody's like me, but I just don't look backwards. I don't go, I should have done something different with it. If I'd had information to make a different choice back then, I might have made a different choice. But I'm comfortable with the decisions I've made in life and comfortable with the path that I'm on. Today, which is a slightly nuanced answer to the question that he has, I'm most personally interested in these medical diagnostic tools and things like that. We have a company, which I haven't talked about, called OneCell, which is just fantastic, where we have the ability to take a single cell from a blood sample and tell whether a person still has the cancer that they had. And it's been used on family members and friends. And I think stuff like that is so, this is the biology back about. I'm most interested in this because, I'm not trying to develop a career anymore. I'm in my 70s and I'm very excited to spend my personal time and my ability to scale companies, that knowledge, to help these companies that I think will make such a big difference in the world. And so that's where I'm spending my time. But one of the things we talked about offline, there is so much technology in the world, it's everywhere. If you go back to when venture capital started, with Don Valentine at Sequoia and, Dick Kramlich at NEA, back 40 years ago, technology was such a small world. We called it Silicon Valley for a reason. It was all this silicon. Now it's everywhere. It's all this artificial intelligence. It's in every domain that we look at. And so I'm choosing to spend my time mostly, in the medical arena, this defense company I like a lot, because I'm spending my time on companies that I think have the biggest impact for good as opposed to for making money. Making money is a really good driver. I don't want to be pejorative about that. It's a good driver because it gets entrepreneurs doing exciting stuff. But I'm in the do-gooder part of my life, and I like it.
And why do you focus on diagnostics as opposed to medications?
As opposed to medication?
Medications, yeah.
That's another good question. In case you guys don't realize that, I think this is a good question right here. That's a good question. Therapeutics, as opposed to diagnostics, we have one company that's creating therapeutics, and it's a really, really interesting company. But therapeutics, to me, are less interesting. They're just sort of single indications. Fantastic stuff, right? I mean, every bit is good. But also, it's a very, very long road, to develop a drug, develop a therapeutic. Whereas developing systems and processes, for diagnostics, we have a company that's created a new age, magnetic resonance imaging machine. These are tools that lots of people can use in lots of different ways. But I think therapeutics are really important. So this is not to, it's a very narrow, it's one of those things, if you're going to do therapeutics, you have to do a lot of them. You have to make a lot of different bets.
Yeah.
And that's just not what excites me. But really important.
Great. Let's go to the next question. And Mahak Sharma is asking, do you have any comments about Synopsys merger with Ansys with respect to electronic design, automation, and simulation, testing space, so on?
I wish I could answer, but I don't know enough to provide a good answer. Sorry.
I'll go to the end here and then move in the opposite direction because we have a few people who asked more than 2 questions. Are there sufficient coding and programming talent available to develop applications at the speed the AI is progressing? What other external limitations exist in exploiting capabilities of AI, or more broadly, what are the limiting factors? And we talked about data. Is talent important? Other limiting factors?
100%. That one bears, a thoughtful response. One of the things long ago I invested in a company called Globant, which is a publicly traded company on the New York Stock Exchange. It's a company that, and I'm no longer involved with them, so this isn't a pitch for them, but I invested in them because they did software outsourcing, developing websites. And I had this idea when I made that investment, which was 10 years ago, that there were never going to be enough software people. And here it is 10 years later, and there just are not enough software people. So one simple answer is, for sure, there aren't enough people. Another interesting part about this is, where are the people? And we haven't talked about geopolitics on this webcast, but America doesn't turn out enough engineers, to put a big dent in this problem. India has a fair amount. So India, there's a lot of work being done because, India has the IIT, the institutes, Indian institutes turning out, software developers, and have been for a long time. It's a huge population. So that is a very a rich area to try to get talent in. And the Indian government knows that there's a lot of work being done. The government to support these new startups and all that kind of stuff. But the interesting piece of all of this then is China. And, everybody knows about DeepSeek and everybody talks about it. And, China has an enormous amount of people, and they have the political will and drive and government support to drive work in these areas. And so when DeepSeek came out, everybody kind of freaked out, like, well, how did that happen? And the answer is, there is a ton of really good talent in China. And that's where a lot of the work is going to get done. And, then there's all the geopolitical mess about whether we get to use it or not. But I hope we do. I mean, I did a lot of work in China in my years at Flextronics. I had a couple 100,000 people there, and I loved working in China. And I hope that the politicians will sort this out. But in answer to the question, there are not enough people. And a lot of them are in China where we don't have access to them. And a lot of them are in India, which is a developing country and developing skill sets. But this, just like the lack of 500,000 radiologists, there is going to be a lack of people to do this for the rest of the time.
So there's a related question here, and it talks essentially about the commoditization of foundation models that, on the one hand, reduce, maybe, that's the question, will they reduce the investment in the underlying chips and the hardware? And on the other side, will they increase the investment in applications? What do you think about the effect of that, the decline in the cost of foundation models on venture capital?
Look, it's a sophisticated question in a sophisticated area. There's a lot of debate in the the scientific community about, for example, was DeepSeek bad for NVIDIA or not? I'm on the side of when things get cheaper, they get used more. And so I think that foundational models getting cheaper and AI, getting more efficient, all that, it's going to just create more demand. And if I can make an analogy that I think will help people, is let's talk about computer memory. I had a friend literally 45 years ago who worked for Hewlett Packard, and he said, there will never be enough memory. That's 45 years ago. And you know what? There's not enough memory. I mean, memory has expanded 1,000,000-fold. I mean, if you think about original, the first computers had like 5 megabytes. And now they have like, a gillion terabytes. And there's never enough memory. I use that as an analogy because that's exactly what's going on here. There will never be a time, in my opinion. I think it's just like memory. These systems are going to get more sophisticated. They're going to get cheaper. They're going to get faster. They're going to run themselves. They're going to improve themselves. All that stuff's going to happen, and there's still never going to be enough. There's never going to be enough data. There's never going to be, And so the fact that they're getting like DeepSeek came out, everybody freaked out about NVIDIA. It's like, I mean, seriously, this is the way of the world. This is what innovation is. I mean, televisions cost $29 at Walmart now, and they used to cost $10,000. I mean, the way of the world is things get cheaper and they become more ubiquitous. And I just think that's fantastic. I don't view any of that as negative, nor do I think it ever gets to an endpoint.
So it will increase both the demand for the underlying hardware and the demand for applications.
And the demand for applications, right. And there will never be an end to it. I really think that. I think memory is a really good analogy. The more of it you have, the more of it you use.
We have a number, the questions we had here are really excellent questions, but unfortunately, we're getting close to the end of our time. So I'll choose one additional question, and we'll try to contain it to 1 or 2 minutes. And the question is, as an AI startup in this area, how do you compete with the tech giants? I guess in the application area.
Yeah. I have 2 very different answers. One is we're in the business of investing in startups that will do what the big companies will never do, which is how innovation works, right? It's innovators' dilemma, if you're aware of that, right? I mean, big companies, we circle back to Intel. I mean, big companies tend not to be the innovators. It's the early stage companies that do the innovation, and then the big companies buy them, or they become big companies on their own, right? I mean, that's just how it works. So I don't view competing with the big companies as any issue at all. I mean, I talked about these companies like the little timing chip company or the Eliyan with the little fabric and stuff like that. Why aren't the big companies? They certainly can. They just don't. So I don't worry about that at all. On the other hand, the one place where it is difficult to compete with the big companies is on what we've talked about for the last hour, which is data sets. I mean, it is very difficult for a startup to get the data that the big companies have. And in that regard, you just don't want to compete with them. And a good example would be electric vehicles. I mean, Tesla, Eliyan talks about it all the time. Think about all the data that Tesla has about all these cars that have been driving and all these things. They have unbelievable data. So for a startup to try to do that, no chance. We would never go near it.
And in consumer markets, distribution is another
thing. If the big companies have the data, I mean, and somebody asked this question when you talked about it, can you buy data? You can buy data, but if you have it and you have massive amounts of it, you have an advantage there.
That's great. Thank you very much, Michael. That was a real treat.
Thank you again. Great fun.
Let's talk about our next event. It's going to take place on April 24th, 9 a.m. And we will be hosting Olivia Nuttbaum, who is the Chief Operating Officer of Box. Box is a leading cloud-based content management platform that helps businesses securely manage, share, and collaborate. Olivia will share her insights on the dual role of AI at Box, both inside the box and out of the box. Inside the box, how do they use AI to manage the company itself and to improve performance, to innovate, and so on? And outside the box, how do they develop tools that help their customers use AI and take advantage of these powerful capabilities to do business in a different way? I hope you will join us for the next event, April 24, and I look forward to it. And now I'll hand it back to Barki for a few final remarks.
Thank you, Haim, and thank you, Michael, for a fascinating discussion. I certainly learned a lot from it. As I mentioned in my opening remarks, we kindly ask that you take a moment to complete our brief survey. You can access it easily using the QR code displayed on the screen. We also invite you to use the link shown on the right to access the Value Chain Innovation Initiative website, where you can find information on our upcoming events and view the recordings of our past events. And with that, we conclude today's webinar. Thank you all for joining us. We hope you have a wonderful rest of your day, and we look forward to seeing you in future events.